Okay, so let's sort of stick with this theory for a moment, this idea of marginal utility, and this idea that as I consume different amounts of each good, that my utility is changing. Now what we're going to do is we're going to introduce a concept in economics which we are going to use for simply illustrative purposes. The math behind it is fairly complicated, but don't worry about that. So all we're going to look at is just the sort of illustrative properties of them, what they can show us. And again, I want to use this as an example, just like I am here with this particular framework, where we can see that the math allows us to kind of say some interesting things about the underlying economics. Again, it's not here to make things more complicated. It's here so we can kind of see that, in fact, hey, if I take, this particular utility function and I increase the consumption of x1 while holding the consumption of x2 constant, I get this fairly interesting looking curve, which gives me a lot of stuff to kind of think about and a lot of stuff to consider as I'm, again, taking these concepts and applying them to the idea of markets and this idea of consumptive decision making. Okay, so what I want you to do now is imagine we're going to stick with the same utility function. Now what we're going to do is we're going to think about all the different bundles of x1 and x2 which yield me the same level of utility. Right? We can see here I have all these different levels of utility stemming from these different bundles. Now what I want to do is I want to think about all the different levels of utility, all the different bundles that yield for me the same level of utility. So let's consider a utility of 20. Again, utility of 20 would imply that I have the square root of 400, which is the product. So all I have to do is think about all the different bundles of x1 and x2, which yield me exactly the square root of 400, which is 20, as I've said previously. First off, this gets us thinking about levels of utility. Remember what I said previously, that when we're thinking about utility here, the numbers themselves mean virtually nothing. What's important is that we can compare bundles. And here we saw what happens when we incrementally change the consumption of one of our products. And so here, let's imagine again that we're comparing levels. So what all of these bundles are is these are bundles, certain amounts of x1 and certain amounts of x2, which yield me the same level of utility. So all of these bundles yield for me 20 units of utility. Okay. So I am indifferent between them. If you gave me these 5 bundles and said pick one, pick the one that yields you the highest level of happiness, I couldn't, because I literally am indifferent between them. They all yield for me the same level of happiness. Now, stick with this idea of indifference. Okay, I am indifferent between these bundles, and the reason why I'm indifferent between them is because they yield for me the same level of utility. It doesn't matter to me whether I have any of them. Let's assume they're all the same price. And if they're different prices, that could matter, right? In fact, I would choose whichever one was cheapest out of these bundles because they yield for me the same level of utility. So it couldn't be a satisfaction thing. It'd have to be simply a money thing. But let's ignore money for a moment. Again, I'm indifferent between these bundles. All right, now, if we look at this, we have 3 different curves here. Okay, 3 different curves. And they look a little weird. They're sort of bowed out. And each one of them represents a level of utility. So if we go back here, I want you to focus on 20 of each good, 40 of one, 10 of the other. And then here we have the same bundle just for reverse. So 20 of x1, 20 of x2, 40 of x1, 10 of x2, 10 of x1, and 40 of x2. These are 3 bundles. I want you to focus on these 3 bundles. All right, and again, same level of utility. Here we have those bundles. Here's 40 beer and 10 tacos. Here's 40 tacos and 10 beer. And here's 20 of both. Right? Here are those 3 bundles, A, B, and C. And notice that they're all on the same line. We refer to this line as an indifference curve. Again, I'm indifferent between bundles A, B, and C. They yield for me the same level of utility. They are each equivalent in terms of the satisfaction I get if I were to consume them. Okay, just like we've been discussing. So each line is a level of utility. And I can think about essentially that between any 2 products, I have utility curves, I have indifference curves, which go out this way. All right, so notice as I consume more, say for example 40 of both products, here at point D, I can see that it's on a higher level of utility. In other words, D gives me more happiness than A, D gives me more happiness than B, and D gives me more happiness than C, for example, right? And of course, D gives me more happiness than all of them because they're equivalent, whereas D is on a higher level of utility. On the same token, E gives me a higher level of utility than D. So again, we want to think about utility as levels, right? We want to think about utility as levels because we ultimately want to compare bundles. And we can compare bundles here. We can say that A, B, and C are equivalent in terms of utility. We can see that D is greater than those bundles. And we can see that E is greater than D, right? This is all our way of us to simply map the idea of utility in a mathematical way. And again, these all come from that same utility function we were talking about before. The actual process of how we arrive at the indifference curve is fairly straightforward. We just take this function, we set utility equal to a particular level, in this case 20 or 40 or 60, let's stick with 20, and then we simply solve this equation for your x, for one of your variables. So for example, we could solve it for beer, and then we could just plot out the different values. We could literally just plug in values of x1 and x2, and it would allow us to plot out these indifference curves. We're not going to do it, but again, I just want you to kind of see this is how economists see consumption. I want you to see a little bit of how the sausage is made, so to speak. Now, the shape of the indifference curve is crucially important here, and it's actually shaped by our preferences. And when I say it's shaped by our preferences, I want us to go back for a moment and think about marginal utility again. As we can see, and as we saw previously here, we see that as my consumption of x1 goes up, my utility is rising. And we can see exactly how much it is rising by looking at marginal utilities. Now, the incremental change in utility when I consume a particular good and the marginal utility that I have for all the goods that I consume is essentially what establishes my willingness to buy those particular goods, right? My willingness to consume an additional unit of this good as opposed to an additional unit of some other good, right? It's about preferences. It's about I prefer bundle A to bundle B, or I prefer bundle B to bundle C, so to speak, right? And in a sense, we want to have some consistency there. So if I prefer bundle A to bundle B, and then if I prefer bundle B to bundle C, then economically speaking, we would almost assuredly prefer A to bundle C, right? It's just, again, just a way for us to think about preferences. I have a preference for one bundle over another. And again, the way that we think about this is we think about it in the context of utility. So I prefer bundle D to A, B, or C. I prefer bundle E to bundle D, right? We want to think about it this way. I have preference. Okay, so your preferences are related to your marginal utilities. And specifically, it's the slope of your indifference curve. Now, we can see that the slope of the indifference curve is not constant. These are not linear functions, so the slope is changing. The extent to which the slope is changing is going to be determined by your marginal utility. Specifically, the indifference curve is a ratio of your marginal utilities. Basically, how happy am I going to be made by an additional unit of tacos versus how happy am I going to be made by an additional unit of beer? I'm just comparing the two products, right? We can see that when I have a lot of beer, right, I'm willing to give up a lot of beer to get just a little bit more tacos, and I'm still on the same indifference curve. Notice that, right? So think about this. Think about this bundle up here, which has a lot of beer and hardly any tacos, and then think about this bundle, which will be right here. This is virtually the same number of tacos, but a lot less beer. So I'm willing to give up a lot of beer to get just a few tacos if I'm already, say, consuming a lot of beer. Now, down here, it's the exact opposite. If I'm consuming a lot of tacos, I'm willing to give up a lot of tacos just to get a little bit more in beer. And notice that this is all about staying on the same indifference curve, right? So this, again, this tells me my willingness to substitute between beer and tacos. It's essentially what the slope of my indifference curve is. It's my willingness to substitute tacos for beer, okay? And so when I have a lot of beer, I'm willing to give up a lot of beer to get just a few tacos. When I have a lot of tacos, I'm willing to give up a lot of tacos to get just a little bit of beer. And then, of course, if I'm consuming somewhere in the middle, then I can see that my willingness to trade off is essentially equivalent, right? So if I were to say, if I'm consuming at 20 and 20, if I want to go to 21 and 19, or in this direction, or 21 and 19 in this direction, I can see that the trade-offs are much closer to 1-for-1. So again, we have diminishing marginal returns. It shows up once again. So if I'm already contemplating a lot of beer, I'm willing to give up a lot of beer to get just more tacos. And if I'm contemplating a lot of tacos, I'm willing to give up a lot of tacos to get just a little bit more beer. Again, diminishing marginal returns shows up once again. Okay, so the other thing that's important about the slope of the indifference curve is that ultimately, in fact, helps us establish our optimal bundle. And specifically, because our optimal bundle is going to be determined by our willingness to consume beer and tacos, or X1 and X2, then we want to think about this. Okay, so here we have that same two indifference curves as before, but now what we have is a budget constraint. Okay, so notice here I have this this indifference curve and this indifference curve. The bundles are different, so that's what's confusing me a little bit. But we have this indifference curve and this indifference curve, right? We can see those right here. So again, the bundles are different, so kind of try to ignore the bundles. Anyway, so if we look at this, we just plot a budget constraint. Here we can see our budget constraint is $320 when the price of the two goods is both 4. So we can see again how we construct budget constraints is we ask ourselves, what's the maximum amount of the product I can consume? If I spend all the money on that particular good, that would be 80 units of beer and 80 units of tacos since they're the same price. So now when I put the budget constraint on the graph, I can see that it intersects my lower indifference curve in 2 places, at point E and at point F. And I can see that it doesn't really intersect, but it's tangent to my indifference curve here at point A. Notice it doesn't touch point B or point C, but it does seem to touch point A. Now, a couple things should jump out to you. First off, notice that I can afford 3 of the bundles listed here. I can afford bundle A, I can afford bundle F, and I can afford bundle E. None of the other bundles that have been listed I can afford. I cannot afford C, it's beyond my budget constraint, and for the same reason I cannot afford B, it's beyond my budget constraint. Notice, however, that while I can consume bundles A, F, and E, that bundle A is on a higher level of utility than is bundles F or E. So while A, F, and E are the same price, $320, I can see that I have a preference for bundle A. In fact, it makes me quite a bit happier than bundles E or F would. Now, again, consumers tend to prefer bundles in the middle. So notice, again, if given the option of consuming bundles A, bundle F, or bundle E, despite the fact that bundle F and bundle E are the same cost as bundle A, I have a higher preference for bundle A. It maximizes my utility. And in fact, if I were to consider that I want to spend my resources in the most efficient way possible, that is, I want to spend all of my resources in a utility maximizing way, I should notice in fact that A is the absolute best bundle that I could consume. Notice that both C and B give me the same utility level as A, but I cannot afford them. With A, I can both afford it and it allows me to consume on this high indifference curve. Otherwise, if I consumed E and F, I would spend all my resources, but I would do so inefficiently because I'm less happy at E and F than I am at A. Therefore, we can establish that the optimal bundle will be found when the slope of the indifference curve is equal to the slope of the budget constraint. Again, we refer to this as a tangency condition. So I'll say it again. Utility maximization occurs at the tangency of the highest indifference curve that someone could afford to consume on. So you can think about it as there's all these indifference curves and they're all coming out from the origin, right? And you sort of track them all the way up and they keep going up and up and up and up. And you would certainly want to consume way up here, but you can't because you have a budget. So what do? You consume the bundle on the highest possible indifference curve that you can afford. And where will that be? That will be where the slope of your indifference curve is equal to the slope of your budget constraint. And we see here that that's at point A. Now again, you need calculus to perform the math in order to make these calculations, but you don't need calculus to understand what's going on here. And basically all we're saying is that your budget constraint establishes what you can afford to consume. Your indifference curves establish what levels of utility different bundles yield for you. So the process is, I will consume the bundle that yields for me the highest level of utility that I can afford. And it just so happens that that bundle is located where the slope of your indifference curve is equal to the slope of your budget constraint, right here at point A. Okay, so as I said before, we have two rules for optimization. The first is you spend all of your income. Notice point A is on my budget constraint. And second, the slope of the budget constraint, which by the way is just the ratio of prices, the price of tacos divided by the price of beer, which is -1 because they have the same price. So the slope of this line is -1, which we can see. So must be equal to the slope of the indifference curve. And as I said previously, the slope of the indifference curve is simply a ratio of marginal utilities. So we need this, which is the slope of the budget constraint, to be equal to this, which is the slope of the indifference curve. So we set those two things equal to each other, slope of the budget constraint, slope of the indifference curve. We simply move some things around, and look what we have. We have the optimal bundle rule, or the other part of the optimal bundle rule, which says that utility maximization occurs where the marginal utility per dollar of the two goods is maximized. And we've already seen previously that this indeed does yield the utility maximizing outcome across the two goods. The other component about the optimal bundle rule is it actually tells us what we should do when we have different marginal utility per dollar. For example, if my marginal utility per dollar for good 1 is greater than my marginal utility per dollar for good 2, this means I should be consuming more X1 and less X2. On the other hand, if my marginal utility per dollar for X1 is less than my marginal utility per dollar for X2, then I should consume more X2. Think about this. What this is saying is that on a per dollar basis, X1 will make me happier if I consume an additional unit of it than if I were to consume an additional unit of X2. In other words, X1 makes me happier relative to my current level of consumption of X1 and X2. Here, it's the exact opposite. Relative to my current level of consumption of X1 and X2, if I were to consume more X2, I would be happier than if I were to consume more X1. And again, all of this relates back to this idea of utility maximization, where the goal is to get on the highest level of utility subject to your budget constraint. And I've said this repeatedly, right? Consumers maximize utility subject to a budget constraint. This is the consumer problem. This is the optimization that we've been discussing. I want to